Okay, good afternoon. So my name is Alexander Steiner. I'm actually working and I'm the president of CSI. We're a French company doing hosting mainly and a little bit of old school in some ways. The interesting thing is that we've been in the cloud for quite a few years, and I've been in the cloud into other companies before. And today what is going to be probably interesting to have in mind is that I will talk about the global technologies, but the business still very much being local. So local business and global technologies is probably something that is interesting to have in mind. Actually, one of the reasons I'm actually working on local business is that I've been traveling over 100 flights a year for 17 years. I'm actually only 30 years old. Just kidding, of course, but actually that's one of the reasons I'm now focusing on local business. I've been really tired of traveling. Now, more seriously, I think it's really interesting to have in mind that there are some technology trends that are really global, but there's still a lot of things that do happen on a local-to-local basis. And I can actually remember in 2013, some of you may have been there was actually a meeting in Berlin called Cloud for Europe. And in that meeting, there were some big plans to invest, I think if the number is still right, about 5 billion euros into a large cloud infrastructure over Europe. Thank God it has not been done. So a few years after, in 2015, there was the first RFP for the European Commission to use cloud. And in that sense, they actually have referenced a few players, a few international players, but also what I actually have put together at the time called the Cloud Team Alliance, which was the kind of a, let's say, federation of local players who are actually all local cloud offers. And the idea was very much that, thanks to what Dominique was mentioning before, the CEO of Proximus, that there was that need to show interoperability between the different infrastructure. And the fact that the Cloud Team Alliance was actually selected by the European Commission was an interesting fact to see that against the global player, a group of local-to-local players can actually show something international, completely interoperable, which was quite of an interesting achievement to just be referenced as a start. One thing to maybe have in mind during that trip was that when you want to actually go into the cloud, and a few years back, everybody was talking about what are we going to do into the cloud. Now everybody is talking about what usage of the cloud are we going to be doing. And you need to have local players who can be local champions to also work with the global players. So there's actually quite a way to be able to work with the two sides of the coin. So you have the local, let's say, players working with local regulations, because still in Europe, but it is true in many countries as well, and even though there are some differences between states in the US there's some kind of homogeneous laws, let's say, and regulation. When you come to Europe and the rest of the world, you have some local regulations for taxes, for health, for data protection, even though that has improved quite a lot in Europe, and so on and so forth. So you really are tempted to work with local players. But then you really have to look for local champions, people who can be actually doing and making all the efforts to be able to be local. And I know some of the speakers behind, and especially my colleague from Amazon, will be talking about how a global player can be as well playing local. But when it comes to local regulation, there's still quite some road to be done, and that's at least giving us quite some years to do some business there. But last but not least is that one way to differentiate is very much to work on the services side. And the services side can be remote, but a lot of the services need to be also talking to people and having people to talk to people and making sure that you can show reliable services. And I'm not talking here about infrastructure, but true services. Just to give you a feel, the company I'm now heading has been actually acquired by an investment fund. And the idea is to actually make more acquisitions as well as organic growth to grow into a world where our profitability is quite strong in having a very, I would say, services-oriented way of dealing with infrastructure. So we sell services, infrastructure services, and nothing else. So what could be also interesting to have in mind is that you have to keep in mind that the companies that have been actually from the very start, starting companies, which can actually grow from one day to the other and use a completely cloud infrastructure. So they can rely on the cloud infrastructure because they don't have any legacy. They can rely on a cloud infrastructure 100% because most of their business is online business. So for them, when they start, and for a new company, whether it's a startup or after they grow, that makes a lot of sense. For a company that has legacy, they need to be able to have a mix of local and infrastructure and physical infrastructure, but also the cloud side. So the hybridation is really where you need to be able to play, and in the hybridation side, the services is absolutely key. So again, it shows that there's actually still a market that is split, and I'm talking B2B here, in 3 different groups. The new companies that can be relying 100% on the cloud, the companies that have already engaged into their transformation to become more digital, and that's a lot of the large groups, which are now relying for some of their services, whether it is actually business related or infrastructure related or even production related, can be actually cloud-based, and the ones that are still into a legacy mode, and it's still quite a lot of company. So in that range, there's still a lot of room to actually make business locally, to be able to have services from the infrastructure, but able to actually use global technologies. So right now, for those companies, I would just like to switch a little bit topic, excuse me, and come back to one of the discussions of this morning when we talked a little bit about digital democracy. And I was actually interested to hear that no one took up exactly the challenge of giving it a definition. So I'm not going to give it a definition, but I just want to bring up one thing. What is new in digital democracy, as it is new in most of the other businesses, and what it can bring is disintermediation. Why? Because it's open to everyone. It's direct, because it actually can be done directly from the voters to whatever you have to poll or to digest or to make available to others. And 3, it can be real time. So it's all about disintermediation, like most of the other businesses. It's just another industry, between quotes. So that's just a kind of a reminder of this morning, where I was a little bit surprised that no one picked up those kind of topics. Now, this morning I was also amazed because I was listening to a lot of good messages, but at the same time I was actually thinking to myself that I didn't hear about any real new technology. And actually there's really probably not new technology since the past 5, 6, maybe 7 years when the cloud came up, really. But what has been really new and evolving is usage. So the usage of technology has very much evolved, but the technologies themselves, I don't think, or I haven't seen one, that I probably have missed a few, that have made it as big as what the cloud has done. So that's interesting to have in mind. And there was a big discussion about the workplace this morning, and I was in 2007 head of marketing for a company called Getronics, and at the time I've launched something that was called Future Ready Workspace. And we had big discussions at the time with the Gartner Group to say, why did we talk about workspace instead of workplace? And I was a little bit disappointed to see this morning that we still talk about workplace when there's still, and especially when we talk about digital, having to put in front of everybody a digital workspace so that you can actually work from anywhere. So it could be that we're talking about 2 different themes there, but I was actually a little bit disappointed by that. Now, what is really new, though, is that there's a real requirement to go more into what can be brought from the digital space into education. And when we talk about education, the one thing that I really talk about, and what I mean, and that's going to be something that Matt is going to be, I'm sure, talking about one way or the other, is how to actually interpret data. And the whole education about data coming from the digital space is really something that needs to be evolving a lot. And in terms of what should be actually messaging or let's say, kept to be tuned to something new is probably in the education side of those data. And actually that's one of the keys there, and the data scientists, as you all know, have a lot of work to do in front of them, and there's a lot of business opportunities for them, or job opportunities, and that's probably the one key thing that came out of this morning. Now, when we talk about the panel that just took place, there was quite a lot of topics that were a little bit newer, I would say, in terms of technologies. But if you would ask me what are the top 3, I would say, technologies coming up that are very important to the technology world. One is anything that has to do with storage. So, of course, capacity of storage for data. But what I talk about, when I talk about storage, I also talk about power storage. So storage as a theme, overall, data and power, is something that has to show some new and evolving technology that should be quite interesting to watch. The second one has been mentioned, but it's about artificial intelligence. Artificial intelligence into everything. So it's not just that we know how to do machine learning, it's not that we know that there's something that can be evolving on itself and that we can rely on a virtual assistant to do that or the other thing. It's just that artificial intelligence is becoming invasive and everywhere. So that's another theme that should be coming up more. And the third one that we've talked a little bit but just touched upon in mentioning Pokemon Go, but it's actually a bit wider than that, is augmented reality. in augmented reality, a lot of the things that were actually discussed this morning or this afternoon are going to be coming to everyone. So we talked about the famous, or now famous, Rolls-Royce engines for planes. Well, with augmented reality, you can almost fix it remotely and so on and so forth. So anyway, those three topics are, to me, the three really big themes that are going to be making new technologies quite interesting. Number one is storage. Let's focus on data for now. Number two is very much the artificial intelligence. And number three is augmented reality. And the last thing I would mention on those three, and it's probably a way to come back to what Dominique was saying also, is that it could be three domains for technology in which regulation can be quite important in the speed and in the way it's going to develop, so that we make sure that we don't actually create too much of a mess into our society. So with that, I will hand over to the next speaker. Thank you.
Hi, my name is Christian Zahorski-Philippe. I'm head of sales for Pan-EU for Amazon Web Services. So I'll take you today through a bit of what we do. We're not necessarily spoken about that much. We like to give examples of what our customers do, so I'll give you a few examples of what our customers use AWS Cloud for, and actually some of you guys as well, how you use us. So let me give you some basics about Amazon Web Services. So there's four elements that we define cloud computing by. The first one is on demand, so being able to use compute, storage, any other services as you need it, when you need it, only when you need it. The next one, the next definition we think about is uniformity, so being able to use across the world our services in a uniform way. So what works in one place should work in another one, it should scale up, should scale down, and it should be easy to use. The third definition that we use cloud computing with is pay as you go. So you only pay when you use. There is no need to pay upfront. There is no need to pay subscriptions. If you use it, you pay for it. If you don't, then you don't pay for it. And finally, it's availability, making sure that the services we provide are always there available for you, but also being able to build services that are defined on your availability. If you need more availability on services, being able to combine those services to make your applications more available, for example. If you need storage to be more available, be more consistent, then you can combine storage methods and actually make more, have higher service levels for that. This is how we think about cloud computing. Our Amazon Web Services business model functions on four principles. Economies of scale. The more customers use certain services, the more we can scale, the more we can lower our cost structure, because we can purchase at a higher volume storage devices. We can purchase at a higher volume compute devices. And our principle after that is to pass on that saving to customers. The example to that is that since 2006, we've reduced our prices 52 times. Actually, we've announced a price reduction that's going to take into effect next month. It's our 53rd. What that gives to our customers also, it gives a rapid pace of innovation. What customers individually try to do in terms of innovation can be done at aggregate scale, and that's what we do. So based on the customer demand, we always innovate on their behalf. So instead of having customers having to innovate in their own individual silos, we innovate on them. Actually, the result of that is Gartner. Gartner's definition of AWS was that it's positioned the highest in execution and furthest in vision within the leaders quadrant. So if you look at the top right, you look at where Amazon Web Services is. Worldwide, enterprise customers use us. I'm sure you're not surprised. I'm sure you recognize some of the names there. You can look at Salesforce. You can look at Pfizer, Kellogg's for your breakfast, the Discovery Channel, for example, the Coca-Cola company. Those are all companies, enterprise companies that use Amazon Web Services. But what's available to those enterprise customers is also available to public sector customers. So if you look at some of the examples we have within public sector, within government institutions like you guys, you've got the Swiss government, or UCAS, which is admission service for the UK government. Transport for London, which I'll give as an example a bit later. The European Space Agency, and also some other US government agencies. If I took an example of UCAS, for example, they've had for, I don't know, many years, their website was crashing. What UCAS does, I don't know how familiar you are with, but in the UK, there is one day in the year during the summer where all the students check their results and actually look where they're admitted. As you can imagine, every student goes and looks at their logon, then tweets their grandmother or emails their grandmother to actually check it. Look at the high grades I got, multiplies, which means that every day, every year, once a day, there's a huge spike of traffic. What UCAS has done is they've used Amazon Web Services to actually cater for that spike. So most of the year, they use very little compute. And then during that spike, during the year, they augment their capacity and pay just for that. So instead of provisioning all year round for that capacity, they just provision for that day for that capacity. Made a huge difference, and that website has been available for the past 4 years. In terms of our infrastructure, I think my colleague earlier spoke about data availability. Where is data? Let me take you through a few examples. So how we define our global infrastructure is through 2 or 3 key concepts. The first main one is the concept of region. We've got 15 regions today. In Europe, I'll take you through a bit the ones that are in Europe, but those regions are uniform and placed around the world. What's important to remember is our regions are segregated. And what that means is that customers choose where the data is within those regions. So Amazon Web Services, if you put your data in one region, it will always stay within that region, unless you decide to move it. Which means that they're by design, isolated. Which means that by design, the data will not move outside of that region, unless you choose to do so. Which, if you think about it from a European context, if we have 2 regions in Europe, we've announced 2 more, but today we have a region in Ireland and a region in Frankfurt. You can build scalable application, redundant application, with the data never moving outside of the EU. Of course, there are certain services that need the data to be moved out, which is what we call edge location, which is when you need to service your customer closer, which you can use. But the core infrastructure, you can build it, is within the EU region. In terms of services, I think if there's developers around here that code, probably know or frustrated by this principle, get an idea, got a great idea. And by the way, this applies to startup, but it also applies to project within government. So you get here, oh, well, maybe next year we'll be on a roadmap, do this change order. It'll take 2 months to execute. Oh, we can't do it. Well, on Amazon, it's very different because what you do is we've got a huge palette of services. I'm not going to go through all of them, but you can pick and choose what service you use and just code for that service or just design on that service. And again, those services are uniform and available in regions within Dublin, for example, or Frankfurt. So you can decide where that service is going to run, where the data is going to be living. An example I said I would talk about earlier is Transport for London, TfL. I'm sure most of you have been in London. There's about 30 million journeys happening on an average day in London. Huge infrastructure that works rather well. Well, TfL decided to use Amazon Web Services to support that infrastructure in terms of presence on the web. So that application does arrival prediction for the tube, the DLR, the river, the buses. It also controls up to a certain extent taxis. And every day they have to do 130,000 arrival predictions and publish that to the world. Well, most days that's okay. I mean, that's an infrastructure that runs pretty consistently. I mean, it's large, but it still runs consistently. What happens is, apparently my colleagues in Amazon always say that winter's coming, but snow days arrive. And then what happens is you've got a peak of users asking for that information, asking when is my bus going to arrive. Well, if TfL had to cater for that all year round, they would have to cater for those storage capacity and a CPU capacity all year round. What they can do with a cloud infrastructure is cater that spike and scale up on that spike automatically and then scale it down. The previous CDN solution had a limit. It had 20,000 requests per second. Now they can scale up the CDN as they need it and pay only as they need it, and then scale it back down. So, cloud allows you to move your expenses from fixed to variable, so it allows you to only pay when you need it. You don't need to guess what your demand is. If your website is going to be very successful, if your internal application is going to be very successful, you don't need to know it in advance. You can scale up as it becomes successful. You don't need to manage infrastructure. Most businesses and most government organizations are not in the business of running infrastructure. We do that on their behalf. And finally, because it's consistent, you can go global in minutes. You can go global within the EU, or you can global within the world. If your application needs to service satellite data all around the world, you can do that consistently very easily. But what a true cloud computing infrastructure allows to do is allows you to choose. I don't think anybody should be able to dictate what application you should be using, what database you should be using, what storage devices you should be using. So within Amazon Web Services, what you can do is you can use Microsoft application, or you can use SUSE Linux. You can use Ubuntu or Red Hat. In terms of databases, you can use Microsoft SQL to MySQL, or DynamoDB, for example. Or, for example, quite innovative new databases like Amazon Aurora. But you should be able also to change your mind relatively easily. I mean, going from an Oracle database to a MySQL database on-prem is very, very hard. Within cloud, you can experiment and you can try. So if you actually want to start with an Oracle database as your backend, you can do that. And then very, very easily move, if you decide to do so, to an Aurora database or a Microsoft SQL database. This can be managed or you can host it. It's up to you to choose. Finally, security. I think my colleague earlier mentioned security being one of the big concerns. Your cloud provider should and has to be certified and accredited. You going and checking a data center is not a scalable way of doing that. You have to rely on international certifications. Those are some of the ones that Amazon has. But that's all well and good, but you should also be able to control your infrastructure. And services like, for example, Amazon Web Services CloudTrail allows you to view every single interaction that has happened in your infrastructure. In today's in an on-prem infrastructure, it's extremely hard to do. It's extremely hard to keep all the change requests that happen in your environment. In a cloud environment, it's a software. It's a software switch, so you can actually track all the changes. In terms of what the industry says about us, the Forrester Wave, you can actually see where Amazon Web Services is rated in terms of leader by Forrester. Just to give you an idea. Finally, just a small nod to some of your colleagues that have started using Amazon Web Services. So Digit A3, they have launched their first website on Drupal on Amazon Web Services. You can look at the infrastructure there. I should give you a bit of a, I'm sure you can read what's there, but I'll give you a bit of a point. The guys came to us and said, well, we're going to have a high peak of traffic. We're going to have one peak load for 1 million users for 10 hours. I think they were going to say it's twice a year. I think that's what they predicted. I wanted to see what the cost was going to be. So we looked at the infrastructure, what infrastructure and a bill, and the bill was about, for each cost, it was going to be $50. $50 each time there was a peak load of 1 million users per hours for 10 hours. 50 euros, so 100 euros over the year. So just to give you an idea of the cost difference. Try to do that by trying to do it on-prem, and the problem is much, much, much more different. There you go. Hope this gives you quite a summary of Amazon Web Services. Have any questions, give me a shout over email. There's a few of us as well in the audience if you want to ask us. Thank you.
Okay. Thank you very much.
Thank you very much for having an English person on stage in the last slot of the day. I did try and buy an EU tie, but there aren't many of those on sale at Heathrow right now. So I just wanted to do a quick introduction. I'm not really going to talk about Splunk that much, but really what we've seen from government and public sector customers. Splunk, everyone asks about the name. It comes from the word spelunking, which is an American word for going and looking in caves to find interesting things. And we're kind of that for big data. So if you've got lots of information and lots of data, how do you go and find the one thing that's really interesting? So it was really, the idea of this technologies of the future. So if you think of Gartner, and this is their near technology trends for this year and the next couple. And there's some very interesting things that they talk about, but it comes down to three main things. How do I protect citizens and these digital services and this digital transformation thing that we're talking about? How do I serve citizens and employees? And how do I grow and do new and interesting things with cloud the Internet of Things, artificial intelligence and machine learning. So how do I protect, serve, and grow? And this is what we've really seen from the customers we've got here, here in EMEA and in the US. And if you look at those priorities, there's some very interesting ones. You know, there's security. How do I make sure these things are secure? Modernize. Awareness of what's happening right now. How do I take the things that are going on in customer experience and apply those to citizens? How do I transition to the cloud? You know, you saw some great examples from AWS. How do I become more efficient internally? And how do I, you know, make sure that I'm controlling fraud and abuse and waste? But we don't make it very easy for ourselves, you know, across, you know, both the UK government and across the EU. There's these different silos that stop us transforming. You know, it could be security, it could be DevOps, it could be the applications we have, it's the network, it's the infrastructure, it's cloud, it's our own operations. But these things kind of tend to live in isolation, and that can get in the way of us actually transforming and kind of putting the focus where it should be. And so, you know, from what we've seen, and I've got some examples as well, a lot of this transformation in government is going to be underpinned by the data that we can get to. And we already know a lot of this data. We know structured data. We've had relational databases and spreadsheets and nice columns and rows for a long time. We're kind of all right at doing that. There's all of this human-generated data. So, you know, just think of the tweets that are coming in right now. There's a lot of data that goes with that from the interactions that we have now. But then there's this other class of data, and it's machine data. And it's streaming at you in real time. And it's coming from everything. It's coming from AWS CloudTrail. It's coming from sensors. It's coming from every piece of IT that runs, every connected car, every Fitbit. All of these things are generating large amounts of machine data in real time. And it's not really that structured. It's just big lumps of horrible-looking text. But there's great value in it if we know and we can get to it and we can start to use it. So there's the data that we know and we use today. It's those databases that we have, those data warehouses and the spreadsheets. But there's all this data that we don't know that we have or we don't use. And that typically tends to be machine data. But you heard about CloudTrail. There's a record of everything that's happened in this data, but we're probably not using it as well as we could. But if you do, and this is what we've seen from the government agencies and companies or government organizations I'll show you, there are some great benefits. And so we can do more with less. I can secure and protect things. I can use that CloudTrail data or other data from all of my networks to say, am I secure? And start to predict what looks like some kind of insider threat. And I can start to manage a more complicated technology landscape. It's great we can do all of these things, but are we creating new problems as we add another silo or try and join them together? How do I make better decisions? Analytics has a very important part to play. You know, there was a lot of conversation in the previous technology discussion, but how do I start to just predict what's going to happen next? You know, being able to do that, a very limited set of really machine learning, but how do I see what's going to happen next? How do I get a better view of my digital infrastructure and share it across all of government? If I'm doing something great in one department with, say, AWS, how do I make sure that I share that infrastructure across all the different departments? And how do I make that data accessible and usable and valuable to everybody across government, from IT to security to those people focused on that experience for the citizen? And as we do this, and as we go through this, we're going to have a different set of technology providers. Some will be outsourced, some will be cloud providers, and there will always be some stuff that stays in-house, potentially. But I've got to marry that up with how am I going to do new and interesting things with the Internet of Things and big data to create these new services. So we've seen this in some of the customers that we've got. Here are some names. We didn't plan UCaaS. Maybe we should have synced up AWS and us beforehand. But yeah, so UCaaS, you heard the story, but they're monitoring AWS and other services with Splunk. You've got the European Patent Office, you know, who are actually looking at how are people engaging with their services. CERT EU, I'll talk about in a minute, a couple at the NHS. The Ministry of Defence talk about operate and defend. StatNet are monitoring kind of the power supply and the power grid in the Nordics. Dubai Smart Cities, Airbus to make sure they're secure. Lots of tax agencies who never want their logo on anything, but there's lots of them kind of using this machine data for that operate, defend, and protect, and build. A couple of examples. We talk about time to value from this data. So Deutsche Bahn had a hackathon. I think there's a hack event going on at the same time as this one. They got a load of people in and said, right, here's some data. Show us what you can do in 24 hours. And by using that machine data that was coming off tracks and trains, you could then go back to them and say, right, you're going to have more delays between Hamburg and Frankfurt than Munich and Frankfurt because the sleepers are made of wood and it's been raining. And in 24 hours, that's the insight that you can get from this data. Gatwick Airport, if anyone's flying back to Gatwick Airport, you should get through security, fingers crossed, in less than 5 minutes, because they are capturing the data from the lasers that park the planes, the boarding card scans, the luggage, all the different systems across the airport to give you analytics to show how did we do, how are we doing right now, and how are we about to do. And the CEO has an Apple Watch to show the state of the airport. So there's interesting things that you can do with this data to build new services and possibly change the business model. The National Health Service, they actually renamed themselves NHS Digital, and they're down to, they are trying to get patients to look at services online and not just diagnose, but also they had a campaign from couch to 5K. And they got about 200,000 people running off the back of this campaign. So they're delivering new healthcare services digitally by using this machine data. And I think they've got it down to about 1.5p per visit to the website, which obviously is taking a lot of burden off doctors. And the last one really is CERT-EU. Some of you may know this very well, hopefully, but they are using their machine data to be able to protect a lot of the services that you would use in government and in public sector and in the EU and the EC. But they're doing that by looking for patterns in the data and being able to say, I can see I'm secure now and I've taken a baseline of what looks like normal, but this looks like suspicious behaviour. And you can imagine that the security threats on the EU are very varied from lots of different places. So they can see that from the data and behaviour to look at what might be a particular threat. And with that, thank you very much. And we're on to the panel.
Thank you very much.